This lesson, we're going to be combining like terms. So for the do now, what is 2x plus 5x? Hopefully you know that that's going to be 7x. So when can you combine terms? And that's when they are like terms. And in order to be like terms, they have to agree in variable and exponent. So they must agree in variable and exponent. So the question would be, which one of these are like terms? Maybe more than one, maybe none of them. Same base and different exponent, 3x squared plus 2x. Are they like terms? And the answer should be no. Get this back up. What about if you have different bases but the same exponents? 3x squared, 3y squared. Well, they're not like terms either. If one exponent or one base is the same, but not everything is the same, then again, no, they're not like terms. If almost all the bases and the exponents are the same, like this next example, well, they're still not like terms. This last one, same base, same exponent, different coefficient, that's when they are like terms. It's 3x squared and 2x squared. The fact that we've got x squared to x squared, we do have like terms, and then this becomes yes, and if we actually solved it, they would just be 5x squared. When you're adding like terms, you don't add the exponents, you just add the coefficients. And that's really what's on this particular slide. So when adding like terms, the variable or variables never change. You're only going to add the coefficients or maybe subtract, depending what kind of problem you're doing. So as you look through these problems, you have to realize whether they're asking you to add or subtract. And whatever they're asking you to do, you can only combine like terms. So this first one they're telling you to add. Well, I've got r to the fourths, r to the fourths, which means I have a total of 7 r to the fourths. Then you have negative 9r cubes and positive 8r cubes. So in this case, you have negative 1r cubed. You don't need the 1, it's okay. And then for coefficients, you have negative 8 plus negative 8, and that should give you negative 16. So in combining like terms, you've got 7r to the fourths, negative 1r cubes, minus 16. So that's going to be set up as, that's the horizontal approach. The second problem is done with the vertical approach, and the like terms are lined up nicely for you. Again, you're adding y squareds, 3 of them, and 2 more y squareds are 5 of the y squareds. 7y plus 7y are 14 of the y's. 8 minus 3 is positive 5. That's your final answer for the next problem. When you subtract, you have to realize that you're subtracting everything in the second parentheses. Some people talk about keep, change, change. If you want to do that, that's fine, but this would be keep, change, and then this would be change all. So what's happening here, if you're going to do it as keep, change, change, you're really saying the first parenthesis is exactly how I have it. I'm going to change subtraction to addition, and then I'm going to change everything in the sign of the second. So x squared becomes negative x squared, 3x becomes negative 3x, and negative 5 becomes positive 5. And then I look at my like terms again, and my like terms would be here. 2x squared plus negative 1x squared, 2 minus 1, 1x squared. Positive x, negative 3x, negative 2x. Negative 3, positive 5 is positive 2. This would be your final answer. If you choose to do that same problem without keep, change, change, so I'm going to keep the answer up. I'm going to erase this right here. Then what you have to ask yourself is, if I were to do 2x squared minus 1x squared, I do in fact get 1x squared. If I did 1x minus 3x, I would get negative 2x. If I did -3 minus -5, that's like saying -3 plus 5, and that's where the answer is 2. So whether you keep change all, or you just subtract, realizing every single term in the second parentheses is subtracted, it doesn't matter. The next one. If you do keep change all, I'm only changing the bottoms, which means subtraction turns to addition. This becomes a -2y squared, a -7y, and a +3. And now when I add straight down, 3y squareds minus 2y squareds are 1y squareds. +7y, -7y cancel, and 8 plus 3 is 11. One thing that's kind of good to notice here is this particular problem and this particular problem are the exact same polynomials. One's being added and one's being subtracted. And notice how no term is alike. You can't add two numbers and subtract those same two numbers and get any same answers. A couple more examples. So this particular one up top, it might be hard to see it on your screen, but you should be able to see it on your paper. When I combine like terms, in terms of x squareds, I only see one of them. So these are the only x squareds I have, which means I start my answer with x squared. Yx and xy, these guys happen to be the same term. They're written with the commutative property, but they're the same term. This becomes plus 2xy's. Then I see y cubes, but there's only this one y cubed. There's 3 of them, but it's only y cubed showing up one time. The 2y, I've got positive 2y, negative y, which means I've got plus 1y. And what I haven't touched yet is the x terms, which becomes plus 4x. It's a very long answer. I'm not worried about alphabetical order. It's just kind of whatever you see, but you should have x squared plus 2xy plus 3y cubed plus 1y plus 4x. And there's no other like terms. This next guy, subtract. Keep change all, or just subtract. I'm going to see if I've got any like terms anywhere, and I do. I've got 3r's. And I've got 3r to the 4th minus 4r to the 4th. I know that's -1r to the 4th. This time I'm not putting the ones. So 3r to the 4th minus 4r to the 4th is -1r to the 4th. R cubes, I've got sorry about that, let's fix this. R cubes, there's -9r cubes minus 8r cubes. That's minus 17r cubes. And then finally, I've got -8 minus -8. -8 minus -8 is 0. There's nothing left. Here's your final answer. -r to the 4th minus 17r cubed. The next one, the addition one. Again, look for some like terms. We've got x's to x's. 9x's plus -3x's, 6x. -7y, positive 8y, 1y. Again, notice how sometimes I put a 1 in front of the variable and sometimes I don't. That's your choice also. You can either put the 1 or not. It doesn't matter. And then lastly, you've got 15z's positive minus 8z's, and that ends you up with 7z's. Final answer, no more like terms. Again, but this next problem is the exact same thing as the one over here. These guys are identical, except one's add, one subtract. So we should get no same terms when we subtract. What's happening here? I've got 9x subtract -3x. It's kind of like saying I'm going to distribute this negative or plus a positive, and that's 12 of the x's. -7y's minus 8y's, -7 minus 8, -15y. Positive 15z minus negative. A positive minus a negative becomes a positive plus a positive, and you get 23z's. Again, same exact problems. No terms are the same in the final answers. You can't get the same numbers when you add and when you subtract. There's a few more examples that are coming up next. At this point, I'm going to stop. You can feel free to look at some of those examples or go straight to your homework. Okay, so again, you're combining like terms. You can only combine terms that agree in variable and base, and that should be it. So good luck with the homework.